Hi, I am Somikda and I will be solving question number 8 of homework 7. Okay, so what do we have in question number 8? We have been given a Poisson process which is defined as follows. The number n t1 comma t2 of the points ti in the interval t1 and t2 of length t equals to t2 minus t1 is a Poisson random variable with parameter lambda t. Now where probability of the number of points, that is n t1 comma t2, is equals to k, is defined as e to the power lambda minus lambda t to the power k over k factorial. Now if the intervals t1 comma t2 and t3 comma t4 are non-overlapping, then the random variables n t1 comma t2 and n t3 comma t4 are independent. Okay, now at a time moment t, there is no more one Poisson point. So using the points ti, we form the stochastic process xt, which is n0 comma t, and this is the graph which has been given for the xt, which is the one sample. Here we can see for different ti the values of how it is varying according xt is varying, and the each step is of unit length 1. Okay, so the first thing which we have to find is the expectation of the entire x t. So we know that expected value of a Poisson random variable with parameter lambda t is lambda t. Also for intervals t1 comma t2 and t3 comma t4 are non-overlapping. So the random variables n t1 comma t2 and n t3 comma t4 are independent. Right. So the stochastic process xt is the number of Poisson points in the interval 0 comma t. This means that we can write all xt as a sum of n t1 comma t2 plus n t3 comma t4. Right, from here xt can be written as this, adding for each in time interval. Right, so expectation of xt can be written as expectation of n t1 comma t2 plus n t3 comma t4 and so on, since each of them are independent. So we can write expectation of xt as expectation of n t1 comma t2 plus expectation of n t3 comma t4 plus and so on up to the end. So expectation of xt can be written as lambda t by 1 factor e to the power minus lambda t plus lambda t whole square 2 factor e to the power minus lambda t up to n, and the sum comes out to be expectation of xt is equals to lambda t. So the expected value is lambda t. Okay, now for the second part, for t2 we need to find the autocorrelation rt1 comma t2. Okay, so for t2 is greater than equals to t1, xt1 is written as xt1 minus x naught. Also x t2 minus x of t1, this is independent, and autocorrelation can be defined as rt1 comma t2 as expected value of x t1 x t2 divided by the standard deviation, and expectation of x square t is can be written as 1 plus lambda t and the standard deviation as lambda t. So autocorrelation rt1 comma t2 can be written as lambda t1 plus lambda t1 t2. Similarly, if t1 is greater than t2, autocorrelation can be written as lambda t2 plus lambda t1 t2. So in essence, So correlation R T1 comma T2 can be written as lambda times minimum T1 comma T2 plus lambda T1 T2. Thank you.